Hello again. This is the last installment of the fuel setup video. Just a couple little more quick things to go over. Um, I started to explain one little difference between the SMEC and the LM before I just got a phone call. Um, that I want to go over, and I'm going to show you that slope correction thing again, just using the SMEC code. So let's close out this logic module stuff. Open up decal. Decal automatically loads the last calibration file we're working on. That's why a couple times it pops up immediately into this Turbinator LM deal. Okay, let's load Turbinator SMEC. And okay, there's the calibration we made. Okay, two little things to talk about here, and then I'm done with this setup stuff, and then we can get on to tuning. Okay, fuel baseline for map. Fuel part throttle, fuel full throttle. Here is that last slope again, where you can clearly see the imaginary final point. Decal creates this point just so you can change the slope of this line. Normally this is the last point, and this is just the slope that is after the last point to control your fuel curve from, in this instance, 6.8 psi to 28 psi, 29.4 psi actually. Okay, I'm going to show you. Okay, this is how you correct that error. Just to reiterate, it's actually a serious deal because you toast a motor because you think you have more fuel up top than you don't. Okay, I moved it up. I moved it back down. That one's been corrected. Part throttle. Up and back down. I don't know if you can even see that. It's a very small change. Up and back down. Okay. Let's hit save for that. Now, here's the other thing I wanted to quickly talk about. I'll leave this instance of decal open. Now, I'm going to open up the logic module cal. Here's the logic module cal. In the background is the SMEC cal. When I go on the logic module calibration to fuel part throttle, fuel full throttle. Okay, we're both looking at fuel full throttle tables on both the SMEC and the logic module turbinator. You can see those, I created both of these calibrations to be 2.5 liter calibrations, and I scaled them both to 52 pound/hour injectors. As you can see, the slopes of these curves are just about twice, the logic module is twice as steep as the SMEC one. There's the logic module curve. There is the SMEC curve. Both of them are used for fuel full throttle with 52 pound/hour injectors on a 2.5 liter motor. Now, you can see that these numbers are halved. The logic module, the max injector pulse width in microseconds is 24,576 microseconds. And on the SMEC, it's 49,152 microseconds for the overall maximum of that graph. But when you look at the actual hexadecimal data in a bin file, if you read it with, if you open it up with a hex editor, you will see that the values for these tables, just fuel part throttle, fuel full throttle, and fuel baseline from map on an SMEC, or fuel part throttle, fuel full throttle, and fuel no throttle on a logic module, the values of the data are exactly double for a logic module calibration. When I was trying to copy tables from SMEC calibrations into a logic module calibration to try to make a proper 2.5 liter version a couple years ago, when there wasn't really a good 2.5 liter version of a logic module cal, I'm like, well, why are these graphs half? And Rob Lloyd told me that, yeah, they're exactly double. The data is double the value for a logic module calibration as an SMEC calibration in just these three tables. Fuel baseline for map, or fuel no throttle. It's the same table in the logic module, it's just named differently. Fuel full throttle and fuel part throttle. Just some information that you might come across, or you might need to know if you are copying tables from a logic module calibration to an SMEC calibration. So I think that about covers it for fuel setup, at least as far as from standard fuel setup that you might have to do when you're setting up a calibration, a base calibration for your car. Okay, that's it for now. I'll start on my next series, fuel tuning ins and outs, in the next video series. Thanks.